aspects of it. All right. So right here we are now looking at genetic engineering, and there are certain terms that we need to be familiar with. We cannot talk about genetic engineering without being familiar or without being inclusive with these terms. So we have what we call recombinant DNA, and that speaks to the modified DNA. So when you take an organism and you remove the DNA, say for example, you take a bacterium and you remove the DNA from the bacterium, that DNA, we refer to it as the plasmid, and you cut out a section and you introduce a foreign DNA into that DNA. Now, the product of that, when you modify an organism DNA, it is called recombinant DNA because it is not the original. So, recombinant DNA is a DNA that has a foreign section of a DNA in it. So it's not in its pure form or its original form. Clear enough?
Yes, sir.
Then we have the genome, and the genome speaks to the general or the genetic makeup of the organism. So if you take the genome of an organism, that portion of genetic information is representative of the genetic makeup of the organism. So it's like a sample of the genetic information of the organism. And then we have what we call transgenic organisms or recombinant organism. And this organism is the product of the recombinant DNA. So you think about it in light of an organism that is formed as a result of gene technology or genetic manipulation. That organism is not the original organism, and we can see it in a lot of our foods that we consume nowadays. If they are genetically modified, then we can call them recombinant organism, recombinant food, transgenic or transgenic organism. All right? So it is not the traditional organism. These organisms would have inherited or would have had recombinant DNA in it. All right? As we move through the terminologies, we will need to know the term plasmid. And plasmid speaks to a circular piece of DNA normally found in bacteria, and it is the genetic information there, and it is used to insert that of the foreign DNA in the organism. So you think about the plasmid like a CD. I like to put it that way. It's like a CD for those of us who, yes, we all would know CD, maybe not floppy disk, but CD where you it's circular and it has the genetic information. Just picture it that way. And a portion of it is cut out, and then you patch it with a piece of foreign DNA from another organism. So that CD now will not look like the original CD because it has been modified. And then that modified CD is then placed back into the organism. So that would be the modified plasmid. And I would have introduced you to a term before which can be used. What term is that? What term could be used to describe the modified plasmid? We'd have looked at it. It's recombinant plasmid, very good. And it is a vector, very good. All right, or recombinant DNA. All right, so the plasmid is an example of a vector. So let's just move to the vector now. Now, the vector is any agent that is used to introduce the foreign gene into the organism. So I don't want you to misuse or have a misunderstanding as it relates to vector, because I know when you're talking about pollution and you're talking about mosquito and all of those things, vector comes into place. But this is genetic engineering. Vector has a different meaning. So we have to understand the context and to appreciate the use of the jargon. To say a vector in genetic engineering is an agent that is used to introduce the foreign gene into the organism. And an example of a vector, as Christopher would have outlined, is that of the plasmid. It could be that of yeast and even virus. Those can be used as vectors to introduce foreign gene into organism. All right. We won't be going through promoter and genetic markers and PCR. We're not going to be looking at that. But PCR stands for Polymerase Chain Reaction, and it is just an expressed method of mass producing copies of a DNA. So think about this procedure as like a photocopy machine for that of DNA. So it amplifies that of DNA replication. So in a very short period of time, we are able to achieve thousands of copies of DNA, of a single molecule of DNA, using the PCR method. So instead of using, they use enzyme.
Sir, what PCR stands for again, sir?
Polymerase, let me write that, polymerase chain reaction. So it is an expressed method of producing several copies of DNA. I'm looking for annotation. All right, so PCR. Polymerase chain reaction. All right. All right, so let us look at the genetic modification, GMOs, so if you see GMOs or GMFs, genetically modified foods, genetically modified organisms, either we can relate to that these are foods or organisms that have been developed through this process of genetic engineering. So there are several reasons why it is important. I may want to say, and you may want to disagree with me, but we have to understand the premise on which genetically modified foods came about. So we look at it from the perspective of food insecurity or food security, that considering the growing population of the world, scientists predicted that, using or relying heavily on traditional crops, we would be in serious problem to feed the world's population. So when they examine the whole issue of climate change, the inadequate supply of water, the diseases that are affecting certain crops that probably would have, even wiped out some of those traditional crops in some areas, they're saying that something must be done to the crops to ensure that they can improve storage, they can be more resilient to certain conditions like drought, and be able to fight certain diseases or withstand certain diseases. They also think that we could modify the crop so that we could have them all year round. So these were more of seasonal crops that would come probably once per year. So why not use our knowledge, of genetics and genetic engineering to modify these crops so that we can combat these challenges that we would have outlined. So they also they were looking at the whole issue of productivity, that they could improve the production of food through that of genetic engineering. And we can see that most of the GMOs or the GMFs consider the size or the level of productivity that these foods or these organisms are normally of bigger size than the traditional crops. So you go into the supermarket and you look at the genetically modified bell peppers. They are normally very big. They are attractive, and this, it's more appealing. So in terms of the usage of land space, they were also looking at it, that you will efficiently and effectively use land space. So instead of planting an acre of traditional crops and you're getting probably 4,000 pounds of something, when you use that same space for genetically modified foods, you're probably doubling or tripling that amount of food. And so here come the implementation of genetic engineering to improve the conditions outlined. So there's a wide range of foods that are genetically modified across the world, to ensure that our food security. So if you notice, I'm stressing it, food security is a main thing as it relates to genetically modified food, that our food security will be maintained. So without that, we would be in problem. Without the genetically modified foods, we would be in problem to feed the world's population. So we think about it. These are the top 10 genetically modified foods. I think this was in 2010. And for those of us who are probably know of persons sending barrels and so forth from overseas, you will find that most times these are the things that come in the barrel in terms of food, because they are cheap, they are mass produced, they are produced using what we call capital intensive labor. So they don't use mostly manpower or manual labor on these farms. What they use a lot of machines, because they mass produce them and process them to a great degree so that they can be in storage for a long time, for example, for famine and those things in case of disaster and so forth. So we can see corn as one of the top genetically modified foods in terms of it's now it can be converted into cornmeal, corn oil, and so many other things they can get from the corn. So if you notice, cornmeal, for a great part, even if you think that it is expensive here, it is very cheap. I can remember some years ago at my church when we normally get things for food for the poor. These things come down in, several bags of cornmeal, corn oil, and those things, because they are mass produced in the United States and other developed countries to supply and to support food security in developing countries. Soy oil, soy products, again, it's mass produced. We see that in terms of milk and a wide range of products. It can be, so they can convert it into powder and so forth. Cottonseed, again, genetically modified. Those are cultivated on large acres of land in the United States and elsewhere. Papaya, rice, a wide range of things. You look at tomato, you look at the whole conversion of that into ketchup and those things. Dairy products, good. So they even impact those animals in terms of producing more milk. And, you will see that they would have somewhat convert that product by saying that, this product rather has 3% or 4% milk. So they make it up with other substances. Yes. We have Irish potato again that is, widely used in terms of the Irish potato powder. And I made reference to a point where Monroe was using it, by adding hot water to it, and it seems to be mashed potato, but it's not mashed potato. It is the powder that they add the hot water to get it, to have that smooth, texture. And then you look at green peas. Again, that's a lot. It's widely used or produced also in the United States. All right. So as I said now, some of the reasons for genetically modified food, the climate change. So we have to talk about that as it relates to, the change in certain climatic conditions that allow certain crops, not to do well. So the traditional crops, they are accustomed to certain conditions for growth and to produce well. But in light of global warming and, as the whole principle of climate change, it can vary in terms of climate change could speak to, changes in temperature. It could speak to that of the pattern in terms of rainfall, either you're having too much or too little. And, these things impact certain crops. And so the traditional crops, they are not adapted, or they are not adapting to these conditions. And as a result of that, we realize that they're doing poor in terms of production. And some of them will even die down, or, as a result of unfavorable conditions. And so here come an opportunity for scientists to modify these crops to ensure that they are able to withstand very harsh climatic conditions, to survive drought, to survive certain temperatures and so forth, to survive excess rain and all of that. So here comes a reason for genetically modified foods. We talk about the new blights and invasive pests that may come up on those traditional crops. So you can see where genetic engineering now allow for us as scientists to manipulate its genetic information to make these crops more resistant to certain pests and certain diseases that may come upon them, within the growth medium. So these organisms are able to fight off, they are able to withstand, certain harsh conditions. We spoke about food security, which is saying that we are having adequate food, and not only adequate, but access to adequate food all year round. So sometimes we have adequate food, but we do not have access to it. And that still would have some issue lingering as it relates to food security. So despite our country not producing certain things, it is mass produced somewhere else where food can be imported or exported, depending on the context, across borders to ensure that persons have access to food. all year round. So using genetically modified foods